What's poppin', dogs? Mr. Allen here, about to solve some polynomial inequalities in this video. And the way you solve these things is very similar to solving equations, except for at the end, get a little mathematical twist, all right? So I'm going to start same way I normally would, factor by grouping when I got four terms. All right, so I group the first two, group the last two. I can take out an x squared in this one, and I'm left with x minus 6. Here I'm going to take out that negative 9. Anytime this is negative, I take a negative out, all right? Then I've got x minus 6. These two should always match each other, right? Otherwise, you may have done something wrong or you can't actually factor it with factor by grouping. So those two need to match, all right? That is one of my factors, so it's going to be x minus 6. This is actually like a GCF of these two larger terms. Oops, smudged. All right, and then I've got myself x squared minus 9 left over, greater than 0. Now, I can't factor the x minus 6, but I can factor my difference of two squares there, x minus 3, x plus 3, greater than 0. All right, so now I can find out when this equals 0, but I want to know when is it greater than 0. So there's a couple ways to do that. I'm going to do it one way, okay? But first, I got x equals 6 from this one, x equals 3 from this one, and x equals negative 3 from that one. All right, excellent, fantastic, and wonderful. So what do I do with these? Well, we could graph this thing and take a look at the graph. We could also do a number line, okay, and do some test values, which is what I'm going to do on this one because it's more applicable later on when you also do this with rational inequalities, all right? So I'm going to put down my key values here. I got negative 3, I got positive 3, and I've got positive 6. I don't really care about the spacing here. I'm not putting a 0 in as a placeholder like I'd often do when graphing inequalities on a number line, right, with linear inequalities. No, I'm just putting these three values down. Any other numbers on this number line get kind of messy, can get kind of confusing. I've seen kids throw down their test numbers and then they screw things up with their final answer. So only write down these three numbers. That's my suggestion, right? Now I'm going to pick a number that's less than negative 3. Say negative 4, negative 5, whatever. I'll do negative 4. I'm going to plug it into each one of these factors. I'm not worried about what the number actually is. I just want to know if it's going to be a positive or negative, because then I can determine if this thing is positive or negative. And why is that relevant? Well, if it's positive, it's greater than 0. If it's negative, it's less than 0, okay? So if I plug in negative 4, I'm going to get a negative here, so I'm going to jot that down. I'd get a negative for this one, and negative 4 plus 3 is negative 1, so a negative for that one. Again, I don't care about what the numbers are, but if I know it's a negative times a negative, which is positive, times another negative, it's going to be negative overall when it's less than negative 3. Let's check the next one. I'm going to pick 0 in here. It's the easiest one to work with. So I'm going to have a negative for the first guy, a negative for this guy, and a positive for that one. Two negatives makes a positive times a positive is positive overall. Then I'm going to pick like 4, okay? So I have a negative, positive, positive. Overall, that is negative. And then if I plug in, say, 7, all three of my factors will be positive, which is positive overall. With polynomials, you're going to notice that it's usually a negative to positive, or vice versa, right? They're going to alternate signs is what I'm getting at there. Unless I have like x minus 6 squared, it's going to bounce off of that positive 6 there, and then the signs will stay the same. So there's certain things you can look for. You're like, wait, is that right? Because there's a usual pattern that you have with these. Okay, so now I just need to write my final answer. And you can do so with interval notation, which is like the parentheses and brackets, or you can do that with inequalities. It's up to you or what your teacher wants. I'm going to go and show you both, okay, just in case your teacher favors one or another. So when is it positive? It's between negative 3 and 3, so negative 3 to 3, and then from 6 to infinity. Okay, so that's interval notation. Why did I choose parentheses and not brackets? Well, it's because it's greater than 0, not equal to. If it was equal to, all three of these would be brackets. This guy would still be a parenthesis. Infinity is always with a parenthesis, okay? The other way to write this is from negative 3, less than x, less than 3, and then when x is greater than 6. So either one of these is cool. They mean the same thing. Sometimes people do maybe a little more formal notation here. They'll have like brackets, the fancy little teacher brackets with like x and then a line such that, and it's a whole thing, whatever. I like this. This makes the most sense to me. It's the cleanest to me, but either one's cool. All right, next one over here. We got ourselves, again, a cubic polynomial, which I can factor by grouping, hopefully. All right, so I got the first two, the last two. I'm going to take out a GCF. In this one, it's x squared, and I've got myself, what, 2x minus 5 left over. Here I can divide those both by -4, all right? And then I got myself 2x minus 5. Good stuff. All right. Now I'm going to have my x squared and my -4 as one of my factors. The 2x minus 5, that's the GCF of these two large terms. That'll come out, so I'll do 2x minus 5. And then we got x squared minus 4, less than or equal to 0. And then we got the difference of two squares to finish this thing out. All right, -2 and +2. A lot of times with factor by grouping, you're going to see the difference of two squares thing happening. All right, so always be on the lookout for that. So now I can get my three values here. This one's going to be +5/2. X equals 5/2, or like 2.5. X equals 2, and X equals -2. So let's get our number line now. We've got ourselves -2, +2, and then we have 5/2, which is 2.5. All right, we don't have a whole lot of test values in that one. That's okay. It's all good. All good. All righty. So for the first one here, I pick like what, -3? If I plug in -3 here, I'm going to have a negative value, a negative value, and a negative value. So three negatives. Negative, negative, negative is overall negative. The next one there, plug in 0, I guess. It's going to be a negative, and a positive. So negative, negative, positive, right? Because 0 is just going to make the 2x go away, which is -5, -2, +2. So positive overall for that one. And I think we can see how we're going to get a similar pattern going on. But let's keep going. Here it'd be like, I can do like, what, 2 1/4? So if I do 2 1/4, which is between there, this one's going to be negative. This will be positive, and this will be positive. So negative, positive, positive, which is negative overall, right? So if I did 2.5, I'd get 0. So if I do less than 2.5, which is what I'm doing here, right? If you're going to do this in your head, it's kind of a little weird. But if I do that, I'm going to have something that 2 times a little less than 2.5 is going to be less than 5, which would give me a negative for that first factor, okay? And then over here, why don't I plug in, say, like 3? So I'd get, 6 minus 5, that's positive, positive, and positive. So 3 positives. All right. So again, same kind of pattern, but our answer is a little different here because it's going to be less than or equal to 0. So I want to know when this thing is negative. Well, it's going to be from -infinity to -2, but I'm including that -2 this time because it's less than or equal to, so that's why it gets the brackets, union, and then between 2 and 5/2. Nice. Beautiful. And if we want to do inequalities, I would just say when x is less than or equal to -2, and then also when it's between 2 and 5/2. Nice. There we go. 2 different ways of writing the same thing. Your call or your teacher's call, whatever preference they have. Just make sure you follow their notation, not necessarily my notation. There are different ways to write these things. Each has their own purpose and their own, following, right? Some people are diehard inequalities, bro. Some people are like, oh man, interval notation all the way. I flip-flop. I change based on the type of thing that I'm doing. All right, there we go. Have a wonderful day and stay awesome.